Hi, welcome to Fire Ecology Stories. In the last video, I distinguished high severity or crown fire with low severity or understory fire and argued that the high severity fire is often demonized, even though it's perfectly natural and widespread. In this video, I want to address why many consider only two kinds of fire when discussing western conifer forests. Aren't there intermediate fire severities? Yeah. And even though fire severity maps show three distinct classes of severity, for example, corresponding to low, intermediate, and high, you could classify a much larger series if you wanted to. And even though fire does burn with different intensities corresponding with different scorch heights, such as what I've pictured here to correspond with the four colors that occur on a fire severity map, so you can see the unburned, low severity, medium, and high severity. In a real sense, however, looking at all this, trees experience only one of two severities, high or low, and they end up either dead or alive. When you see burned land classified as medium severity, like yellow on a fire severity map, it represents an intermediate level of fire severity, but because a tree is either dead or alive, the only way to represent, say, 50% death is to tally yes and no data across a large area. Thus, within a 100-acre patch, for example, we can say there was a certain proportion of the canopy trees that experienced death, say 95% death, or 75% death, or 30%, or less than 10% death. So this is represented well in this graphic drawn by Mell and Hoffler in a report they did for the Blackfoot watershed, Montana. These different proportions correspond with what many also refer to as different fire regimes. Once again, the key here is that a mixed severity fire regime makes sense only in reference to a specified area, where there was an intermediate level of death across that area. Fire at the point of a single tree is always either one thing or another, high or low, enough to kill a tree or not. Reference to mixed severity fire is therefore more of a reference to the spatial distribution of the non-lethal and lethal fire types than it is a reference to an intermediate fire severity. That's why intermediate severity yellow color on maps is always situated between the high and low. So surrounding the red, you see the yellow, where there's a lot of brown-needled trees, half of which die maybe and half of which stay alive. So basically, there's only two kinds of possible fire at any given point, but there's a continuously variable proportion of trees that die within a specified area. Let's go back to the figure representing different fire types or fire regimes. Now it gets interesting. Most fire ecologists associate certain vegetation types with different regimes depicted here. For example, pure ponderosa pine with a frequent low-severity non-lethal fire regime. Then you can move on to dry mixed conifer forests with mixed severity type A, let's say. Mesic mixed conifer forests with mixed severity type B. And then on up to higher elevation lodgepole subalpine forests with a lethal fire regime. So, associations exist in part because fuel loads increase across that spectrum. That's one justification for wanting to thin forests, to move them back to a structure that carries a lower fuel load and therefore lower severity fire. But here's the rub. Weather conditions during a fire can also affect the kind of fire that results. Notice that as we move from cool, wet, and calm conditions to hot, dry, and windy conditions, the proportion of high severity fire across space also increases. Moreover, weather variables dominate fuel variables in terms of their statistical contribution to the effects on fire behavior. That means it doesn't matter what the vegetation condition is, when weather conditions are severe, you're going to get a high average fire severity. And severe fire will show up even in forests that have been, quote, restored to open conditions, like here in Seeley Lake, Montana, or here in Idaho in the Elk Complex fire, where logging and thinning couldn't slow the fire. Or here, near Flagstaff, an experimental forest where the intensity of this fire was so massive, it was just whipping through the trees. It didn't care how continuous the trees were. That's weather dominance. Therefore, when weather becomes more and more conducive to severe fire, lethal fires move on down into every forest type out there. You see, as it gets drier, hotter, windier, down, everything becomes a lethal fire regime. So you get this? As it gets hot, dry, windy, you get more and more lethal. Cool, wet, calm. Hot, dry, windy, cool, wet, calm. Hot, dry, windy, cool, wet, calm. So, back to where we started. It's a simplification, but they're basically two classes of forest fires: non-lethal understory and lethal crown fire in any one spot, but a more continuous range in the average severity when you move from a single spot to a larger area within which you can measure the proportion of trees that died. That's my take on what constitutes a mixed-severity fire regime. Thanks for listening, and I hope you'll join me next time when I focus on the fascinating ecology associated with the more severe form of disturbance where lots of trees die.